Hello. In this video, I would like to share with you how to graph quadratic functions when written in vertex form. A parabola is the graph of a quadratic function which looks like a U shape that has tails that point up or down. When the equation of a quadratic function is written in this form, f of x equals a times the quantity of x minus h squared plus k, we call that vertex form. The highest point of the parabola if the tails point down, or the lowest point if the tails point up, is called the vertex of the parabola. Fortunately, the vertex is easy to identify when the equation is written in vertex form. The coordinate formed by the values in place of h and k produce the vertex. Identifying the maximum or minimum of a quadratic is easy to do if you look at the a value of the quadratic equation in vertex form. When the a value is positive, the vertex is at a minimum and the tails open up. When the a value is negative, the vertex is at a maximum and the graph tails open down. When graphing a quadratic function in vertex form, we must first consider what we call the parent function, or most basic form of the quadratic equation. F of x equals x squared. When x equals negative 2, f of x equals 4. So we have the coordinate to plot negative 2, 4. Similarly, when x equals negative 1, f of x equals 1. And we have the coordinate negative 1, 1. The remaining 3 points follow similarly. These 5 points are often called key coordinates, and we can transform their locations to any graph of a quadratic written in vertex form. We already know that the vertex will always be located at the coordinate hk, and the a value indicates whether the graph opens up or down. However, the a value also indicates whether our parent graph stretches taller or compresses shorter. When a is greater than 1, the parabola is stretched taller. When the a value is between 0 and 1, the parabola is compressed shorter. If the a value were to equal 1, we would have a parabola the same shape and size of the parent graph, and if the a value were equal to 0, we would not have a parabola at all, but rather a linear equation. Here are 2 examples. First, f of x equals 2 times the quantity of x minus 3 squared minus 2. First off, the location of the vertex is at the coordinate 3, negative 2. It might seem unusual at first to say the coordinate is at positive 3, negative 2, but keep in mind that our definition of vertex form located the vertex at the opposite of h. We always change the sign of the h value, but never change the sign of the k value. Next, with the a value equal to 2, this parabola is going to stretch twice as tall as the parent graph. What this means is that instead of stepping to the right or left 1 unit and up 1 unit, as described in the parent graph, we would actually step up 2 units twice as tall. I actually like to show a temporary axis for this step. From the vertex, we would step to the right 1 unit and up 2 units instead of 1. From the vertex, we would step to the right or left 2 units, and instead of stepping up 4 units, we step up 8, which is twice as tall. As we connect these points with a smooth and continuous line, we see the parabola take shape. For our last example, consider this function. First, identify the location of the vertex and then the a value. Use the a value to determine the shape and direction of the parabola. Please pause the video now and identify these features and try sketching the graph on your own. Resume playback in a moment to check your work. The vertex is located at the coordinate -4, -2, and the graph opens down and is the same shape and size as our parent graph. Your parabola should look like this. Thanks for watching, and good luck in your next examples.